Hello, welcome. This is Birdy. Welcome to a new lesson in Houdini. Today we continue our journey in the Pyro in Houdini. Today we will explore the different fields in the Pyro simulation as a dopnetwork. So we will explain the temperature field and velocity field and density and many other in the smoke objects in Houdini. So let's get started. So let's continue, guys. Explore the smoke simulation and its components. Now we have a Pyro solver. As I said earlier, we was working on the smoke object. Of course, I explained the size, the center, the division size. Actually, it control the resolution for the smoke simulation we have. Okay, so if we make it like 0.05, we'll have much better result. But we should connect this division size by the voxel size inside the volume rasterize attribute in the sub level for the smoke source. So let's take a copy parameter for the division size. Let's go back. Let's go to the smoke object, and here we have the volume rasterize attribute, and we will paste it here. So now, as we can see immediately, the density become much better because we have now a better resolution. Also, to see the smoke and judge it, we have to make a light scene setup. But it's very easy. Just use the sky light. That's all. Don't use anything else. It's more than enough. And in the skylight, enable light in the viewport. That's it. And you can hide both of them in the viewport, but not their effects. Just you will hide their icon only, but they still working. Okay. So let's hide the smoke from the. Okay. Let's choose this. Let's display. Now we can have better. Now we can see the simulation, smoke simulation, and started to judge it and change it. Of course, here in the smoke object we have many fields. All these fields can read inside the smoke simulation, special for the Pyro solver. Pyro solver read them. Okay, but in this example we only have density and temperature. As we can see here, we have the temperature. We have the temperature. If we want to see the temperature, we don't have a fuel. Divergence, I don't think we have a divergence. Burn, we don't have a burn. Heat, we don't have all these things. Collision, source, sink, we don't have, but we have velocity. As we can see here, we have the velocity. If we hide the temperature and play, as we can see now, we have the velocity. We can see the velocity as well. So what's happening here? As I said earlier, let me make this for example. We have a smoke, and this smoke has a temperature. It's hot smoke, so it will rise. It will rise because of the temperature. Okay, because surrounded it's cold. All this is cold. So what's happening that the temperature will rise the smoke, right? until the temperature become 0. So the smoke will start rise up and will start to advect like this. Of course, this is all called advection. This is advection. This is called advection. When the field affected by the temperature or the velocity or the density or all these things, this is called advect. Okay. Okay. So the temperature make the velocity, make like velocity as a swirl, same as in the nature. Okay. So for example, if we make the temperature here 0, there will not be velocity, right? And even if we have velocity 1 here, nothing will happen because we don't really have a velocity came from outside, right? So let's first make the temperature 0 as we see now. So there is no, as I said, velocity at all, or there is no movement for the smoke. So let's make it 1 again. So now it will start to working as we can see now because of the temperature. This is first. Now let's do some change in the shape of the density we have. As we can see, it has a mushroom effect. It looks like a mushroom or a nuclear bomb, something like this, but it's more like a mushroom. So how can we make it looks better? First of all, we should make divergence and variety in the source of the density itself and the temperature. So by that it can give us more detail. Some will start rise from here, and some will start rise from here, and so on. So let's make this. Let's go back here. But how can we make a noise in the attribute? We have an attribute called attribute noise. Okay, now we have the attribute noise. Immediately it works on the color because here type applied on the attribute CD, but we need to apply it on the density. This is first. So now if we open the spreadsheet and we type density, we'll find that the density started to become has a randomization in the number. Okay, so let me explain, but it's still. So first, to animate it, we have to check the animate. So as we can see now, the number will start to move because so every frame the amount or the value for the density will change. Okay. Second, we have the noise type. We choose the simplex improvement. Okay, no problem. You can comparing with all this, but I will leave it on the default. Okay. Third, we have a remap noise. Okay. The remap noise, it's the mode we choose in the here the mode additive mode, meaning here we have a value of close it. We have a value of 1, right? The value of the density is 1. Density, the default times multiplied by the scale equal 1. All the points. So here we have something else. Spreadsheet, we have a different. So what it do, it add this number and this number, يعني the range between -1 to 1 in all the original value for the density. Meaning we have 1 here for the density. Now it will add -1 or to 1. Okay, but this is a float, so we only need just one row, not 3. So I will change it to 1D. Right? So now we have just -1 or +1. So the range 1 -1. So the minimum range will be from 0 to the maximum 2 plus 1 plus 1 equal 2. So the range will be from 0 to 2, right? So here is the range from 0.00. This is the minimum, and this is the maximum, almost 2. So it's almost a 0, positive, 2, 2, positive. Okay? This is the first thing. Maybe we should make it, let's say I put it here minus 0.5. So the range minus 0.5 to 1, meaning 0.5. So it will start from 0.5 to 2, right? Let's type 2. So the range will be from -1, because -2, 1 minus 2 equal minus 1 minus 1, right? Almost -1. So let me say I want the minimum will be 0. So everything under the 0 will be just 0. Yani all this number -0, -9, minus all this number until the 0 positive will be only a 0, as we can see here. All the negative will just, all the value under the 0 will be just 0. So this is the minimum and this is the maximum. And above the 1, I don't want to make it to be more than 1. So as we can see, it range it to 1 or clamp it. Okay, so this is the useful of this 2. I will make it 0. Doesn't matter really the number we put it here. Okay, so it will start from 0 to almost 2. Almost 2. Okay, so I will just make it -1 and 1. Okay, that's it for now. Okay, next we have the element size. The size, we can see it here more if we want. The element size, or maybe we can make it smaller. As we can see, something happened. Maybe we can just make it a surface cutter to be more obvious. Okay, and let's make the particle scale a little small, maybe like this. So this is the polished duration, the cycle of the animated noise for the density. Okay, element size, what size we want, element scale as well, and offset if you want to change the offset, octafast, fractal, and all this stuff. Maybe we can change it to another thing, maybe something Berlin. It's not very obvious, but I will make it like this. Uh-huh. Not sure why it's not. Okay, anyway, so I have 0 to 1. Okay, maybe I will make this one. Let us see. Same thing. Okay, no problem. So, but now we make some noise in the density itself, as we can see here. Spreadsheet, yeah, I think this is a spreadsheet. Yeah, as we can see here now, we have. Ah, I don't know why it is happening, but maybe I will just simply delete this and make another one easier than corrected. Attribute noise. Just put it here and make a density 3D, 1D, and that's it. And of course animated. And let's use yeah, I think it's I'm not sure why it's not working, to be honest. Density, density. Let me check this again. Yeah, okay, so remap, okay. Yeah, as we can see here, it's more obvious, if you can see it. Also, we can make volume scatter. Yeah, but yeah, let's make it a surface scatter for now. Okay, this will be more than enough for the demonstration purpose. We can also make the one for the temperature, and if we want another result, we can make it for the temperature. For one for the density and one for the temperature. But for now, I will just use the density as it is. Okay. So let's go back. We want to select the file, get inside the. Let's start to see. Yeah. Now started to become, as we can see here, it has different things because of the animated noise, as we can see here. As we can see here, it has different result. Maybe we can use a temperature. Temperature. So now the field that will change is the temperature. As we can see here, it's become even the change. We can see the change here now, right? But I think we need a little more smoke. Let's see it, -1. Okay, no problem. But maybe just I can increase. It's better to make it small, but for just to make it fast, I will leave it like 0.1. Okay. Let's go back. So this is how we change the temperature. If we choose the temperature here, now we can see the temperature is changing from a frame to another. Okay. Also, we can do something different. We can use the velocity. Until now, we didn't use any velocity yet. We just used the temperature and the density, but we don't have a velocity yet here. As we can see, we don't have any V here. So let's make the V. The easiest way to make a velocity, of course, in the points as an attribute, just make a point velocity. Maybe you can put it here or you can put it here, but not after the volume, of course. Must be here. Maybe here is good. And if you want to see its effects, check the velocity. Until now we don't have any velocity. Just choose the keep incoming and choose the add curve. Immediately we now see the velocity. If you want to see it better, you can just check the V. As you can see here, now we can. Of course, we have less. Maybe we need more particle. Let's make it 0.05. This looks better. Okay. Still, we need maybe 1.4. Okay. So as we can see now, we have the velocity. We can control it from here if we want. Here, for example, we can make the lens scale something like this, just to see its effects. Let's uncheck this. So now we have the velocity. We can control it from here, the scale, the pulse duration, meaning the cycle of the animate will be fast or slow. Okay. Swirl size, the swirl size, as we can see now, it's become very big swirl. Now it's starts to become small and small, maybe something like this. Swirl scale, if you just want to make it from X or Y and Z, green, and of course here if you want to make it a direct, for example 1. So most of the velocity will be in this direction, but it will also have a swirl noise. I will make it up, as we can see here. So now we have a swirl size. Maybe we can make it a little smaller, maybe something like this. So we still have velocity change in every frame, but here we didn't convert it yet. So let's convert it to volume as well. Of course, to be reading on the dynamic simulation, it must become a volume. So just type V. Now we have it. Now if we type this, we will have the velocity, and it's a vector, right? It is a vector, as we can see here. Vector means 3 direction. It has 3 axes. I don't need to see it. Maybe see this. So let's go back here. Now let's hide the temperature. Let's see the density. Now we have the velocity. If we type here, as we can see now, the effect become very different. I don't know why it's give me an orange. Oh yeah, sorry. It gave me an orange because the composition. I don't know the composition. Let me check here density. Not really sure why it's give me this density. Maybe we can. Oh, of course, this is for demonstration, but we will not change the smoke density in the final. But this helps us in the viewport only. Okay. So maybe if you want to increase the smoke, you can go back. Maybe scale times 2, for example. So we'll have smoke. I'll show you. Go back here. As we can see now, the smoke become much dense, right? Okay. So now we have two things. We have the velocity working, also the temperature working. If we make the temperature 0, only what it will work, the velocity only. So this is the velocity without. This is the movement of the velocity, its effect on the simulation without the temperature. If we check the temperature here, we don't have any temperature, as we can see. We don't have any temperature, but we have a velocity. So this is the movement of the velocity, as we can see. Okay, so to have the velocity back, of course, the temperature, we should use 1. Okay, let's go back here. Let's choose the density. Now we have both the velocity and the temperature. Also, if we need to increase the density, we can increase it as well from here. If I type 2, as we can see immediately, this become, if we type it 5, as we can see, it become much and much darker or dense. As we can see here, the smoke become much dense. So we can control it in both from the scale and also the temperature and the scale. Of course, it only add this number 5. يعني it added 5 times every frame. It added the amount of the density plus 5 times. Plus 5 times, I think it's like multiplying. Yeah. Multiplying by 5. Yeah, it's multiplying by 5. Right? So this, because this is we add, so it's multiplying by 5. So maybe now we don't need to make it maybe 1. Yeah. So as we can see now, the simulation is working from the temperature. If we increase the temperature, meaning we will increase the temperature of the smoke, so the smoke will rise faster and more. We make it 5. As we can see here, it's become very fast. As we can see here, the gas resize is slower than the smoke, so we can maybe make it maybe 2. Yeah, as we can see here now, this is the useful of the padding like this, but this will increase in all the size. Maybe make it 3. Yeah, so now we have it will not be cut anymore in the y-axis. Right? It will every time it will leave 3 voxel, I think, so it will not cut until it stop, until the voxel until the domain will stop getting bigger, as we can see here. Okay, I will make it 1. And also the velocity, if you want to scale it, so the velocity, it multiply by this number, and we see it here. Okay, I hope this is easy to understand and make sense. Do we have anything else here I want to talk about? No particular, it's not important, both of these things, but I think this is for now, for the I think this is good for now. Okay, and that was it for this lesson. I hope you enjoyed. If you have any question, type it in the comment section. Also, don't forget to like the video and subscribe to the channel and share it with your friends. Also, if you'd like to support us, you will find below the video link on Patreon and Gumroad, and we appreciate your support. And that's it for this lesson, and I see you in the next lesson. Have a good day.